All right, friends, today we're going to be talking about ordering rational numbers. Yesterday we talked about the word rational. I asked you what word appears in the word rational, and we defined that as ratio. Remember that a ratio can be written as a fraction, such as 3 cats to 2 dogs, right? And so what a rational number means is it's any number that can be written as a fraction. So that's something that you need to remember. In our first activity today, we're going to use the symbols greater than, less than, or equal to compare each pair of numbers. Be prepared to explain our reasoning. When it says be prepared, it just means how did you think through comparing them. So in comparing 12 to 19, I know that 19 is greater than 12 because I'd rather have $19 than to have $12, and those are positive numbers. To compare 212 to 190, 212 is greater than 190. So I'm going to, so that says 12 is less than 19. So 15 is greater than 1 5/10. That's a decimal point there. They look the same, but they're not. 9 2/100 is less than 9 2/10. On this problem, that's 9 2/10. I use place value understanding there to help me compare the numbers. 6 50,000 is equal to 6 500. So those are the same because a 0 does not add any value to a number. 4/10 and 9/40. In this problem, I have to think through this because one is a decimal and one is a fraction. Well, to find out the decimal version of this, well, I can compare this as this. I could rewrite this as 4/10. That's one way of doing it. And I can look at this like this, 9/40 and then 4/10. I want to change this denominator to be an equivalent fraction. I can do that to change it to 40. And if I multiply that by 10, I multiply this by, so this by 4, then I multiply this by 4. I don't know why I said 10. And that gives me 16. And 16 is greater than 9, so 4/10 is greater. You can also do top and bottom out, so you could say 9 divided by 40, right? You get a decimal point, you'd have to add a 0. 40 goes into 90 2 times. You can see that the first digit is a 2, and that's a 4, so that's another way to compare. 19/24 and 19/21. So in this problem, right, you have 24ths and you have 21st. When you're thinking about fractions, right, is it better to share more pieces? Do you get more of a piece of pizza if there's 24 pieces that you have to cut? Or in the same pizza, do you get more if there's 21 pieces? So in this situation, you're going to say 19/21 is greater than 19/24, right? To do that mathematically, we could do top and bottom out, right? To see, that's one strategy we can use. Or you can think about it as if you had a whole, right, a whole pizza, and you were to cut that into 24 pieces, what would be the size of each slice? Versus 19/21. Like what would be if I had a whole pizza and I cut it into 21 pieces, which one would be bigger pieces? On this one, 16/17 and 11/12. Both of these are fairly close to a whole, right? In this situation, we want to think about which one is worth more. So when you're given a test, a lot of time kids ask, for a lot of questions because the more questions you have, the less each question is worth. So in this situation, because you have numbers that are pretty close to one whole, right, this one is going to be larger in this situation. So we want to make sure that we can check our work. So we're going to do 16 divided by 17. 16 divided by 7. So 17 can't go into that, so we're going to put a decimal and a 0. 17 into 160. Well, if I treat 17 as a number like close to 20, well, 20 can go into 160. Let's see, 5, 6, 7, 8 times. So I'm going to try 8. That's 56. 8, 9, 10, 11, 12, 13, 136. I think I can pull another 17. So I'm going to go 9 times, right? So decimal point 9. So I'm going to add another 17 there. That's 13, 153. And now I want to find the first the second digit, so then I'm gonna be left with 7 and then bring down a 0. 20, 40, 60, so maybe 4 times. Let's try that, 28. That looks pretty close, so that's 94 hundredths, and I'm gonna do 11 twelfths now, so 11 twelfths. Decimal point, add a 0, 12 into 110, that's 9 times, that's 108. You're left with 2, 12 into that is 91. So that works out, so we know that 16/17 is greater than that problem. So that's the first activity that we're doing. It gets harder when you're comparing the fractions, especially when they have different denominators. You can always find the equivalent fraction. That's one strategy to use, or you can use division. So for this next activity, what we're gonna be doing is we're gonna be ordering rational numbers. So I'm gonna be giving you a card sorts to work with today. In the card sorts, you're going to be ordering first just some basic numbers. So, and we're gonna be ordering them from smallest or least to greatest, which means smallest to largest. So in this situation, you're gonna get some cards and you're gonna have to order them. And it's quite a lot. So I have 9/8, 2 and 5/10, 0, 0 has no value, 7, 62, 25, 15, 9, 6, 4, 2, 53, 10, 22 and a half, 14, 8, 5 and a half, 3, 1, 30, 78, 87, 99, 100, 16, 17, 11, 7 and a half, 5, 8/3, 1/4, 29. So the smallest value I have in this set is I have 0, so that should go first. Then I see that I have a 1/4, I have a 9/8. I'm gonna use this 1/4. That seems to be the second smallest. I did see a 1 in this stack, so I'm gonna put that 1 next. And then I saw I'm just looking because it does take a little bit of time. I saw a 2 and a half. I also saw a 9/8. So 2 and a half should be scooted there, and 9/8 should go there because that's an improper fraction. That's a little bit more than 1, but less than 2 because we don't have 16/8. We have 9/8. 2 and a half. Let's see. I have another number here, 8/3. I'm going to see if it's less than 2 and a half. So 3 goes into 8 twice, and you're left with 2/3, which I believe is more than 2/3. If you think about 2/3, a third is 33%. So 2/3 would be 66%. So that'd be 2 and 66 hundredths. So after that, looks like it comes 3, and then 4, and then I have a 5, a 6. I know this is kind of a mess, but I'm just trying to show you that this is the activity we're trying to do today. Oh, I also have a 2 that I missed. So the 2 should be slid in before the 2 and a half. So this is what happens when you don't recognize that you had a number there. And then of course I'm doing this. So 2, so I have a 7 here. I'll put the 7 there. I'm looking to see if I have, I have a 7 and a half, so that should come next. And then I have an 8. Oh, and then I'm noticing other numbers that I'm missing. So then I'm gonna slide this over because I found that I have a 5 and a half. Then I have after an 8, I have a 9. We'll put that up there. I also have a 10, an 11. Doesn't look like I have a 12 anywhere. The next number I have seems to be 14, 15, 16, 17, 22 and a half, 29, 25, 29. You can see me working, thinking, using my brain. That looks like 30's next. 53, 62, 78, 87, 99, and 100. What's going to happen after this is I'm going to give you a second set of cards, and I'm going to ask you to continue to order them from smallest to largest. The only difference in the second set is that the cards that I give you will be negative. So they'll have a negative value, and I want you to be able to reason where these go in this current set that you have. And I know that you can't see all my cards here, but you will be given this set of cards. And so if the numbers that I give you are negative, right, you're going to have to order them based off of their value. Remember, the closer a negative is to 0, the higher its value or the greater it is, and the further away it is from 0. So I have a negative 22 and a half. I'm going to put that at the very beginning because that's small. I have a negative 22, so that goes right there. A negative 3 is pretty close to 0, so I'm going to put it close to 0. I have a negative 1, which is really close to 0, so I'm going to put that in front of the negative 3. A negative 10, I'm going to put that further away from 0. Negative 7, closer to 0 than the 10. Negative 2 and a half, going to put that between the 3 and the negative 1. Negative 1/4 is super close to 0, so I'm going to put that right in front of 0. Negative 9/8, right? So remember, we talked about opposites, and so I have a positive 9/8, and that went between the positive 1, and the positive 2, so I'm going to put this between the negative 2 and a half and the negative 1, because it's greater than 1, but less than 2. Negative 5/2 goes between, so far, the negative 3 and the negative 7. Negative 9 goes in front of the negative 10, so I'm going to scoot the 10 back. Negative 23 is the largest. Negative I have, so it's the smallest. Negative 8 should go in front of the negative 9, and I'll continue to push things back. Negative 5 goes between the negative 3 and the negative 5.5. Negative 2, right, so running out of space here. Negative 2 goes in front of the negative 2.5 and behind the negative 9/8, and negative 7.5 should be in front of the negative 8. So that was this task. So now that we have this task, you're just ordering them, making sure that you understand how to order them from least to greatest, giving negative numbers in this situation. So I'm going to clean up really quickly because that's going to be the hardest part. And so the whole point of this activity is just so that we practice ordering our numbers, both positive and negatives. And then we're going to move into our last activity for today. So it's taking me a second to clean this up. Card sorts, so much fun. So I'm going to put these in the proper bag, which these are set 1. And then I'm going to move into the next activity, and then I'll clean up after this. So the last activity asks us to compare points on a number line. So comparing points on a number line, so it says use each of the following terms at least once to describe or compare the values of points M, N, P, and R. So greater than. So I just need to make use this number line to make a comparison. So P is greater than N. Use that. Less than. M is less than R. Opposite of. So if I look at this, if I treat this as 1, 2, like this is negative 1, negative 2, negative 3, negative 4, negative 5. So M is the opposite of P. Negative number. N is a negative number. And you could say -2, right, because that's what it is. You can say -5, 5. -5 is the opposite of 5, +5. On 2, it asks us, it tells us, tell what the value of each point would be if p is 2.5. So if we're counting by 2.5s now, so if this is 2.5, right, it makes sense that you're counting by half. So that would be half, 1 whole, half, 2 wholes, 2.5, 3 wholes, 3.5, 4 wholes. So r would be 4. This would be, n would be -1 if you're counting by halves. And because p, it tells you p, the opposite would be m, would be equal to -2.5. N is -4/10. So if this is 4/10, then you're counting by 2/10, it seems. So 2/10, 4/10, 6/10, 8/10, 1 whole. So if m is -1, then p is 1 because they're opposites. And if that's 1, that's 2/10, 4/10, 6/10. That make r equals to 1 6/10. If r is 200, what are we counting by there? If this is 200, then that means that this is, I would say 25. 25, 50, 75, 100, 125, 150, 175, 200. So that makes sense. So that means 125 is p, so p equals 125, which means that m equals -125 because that's what opposite means. And then n would be -50. M is -15. So if m is -15, 3, 6, 9, 12, 15, then p is +15. N is -6. Because you're counting by 3s. And then r equals 24. And let's see, that's it for today's lesson. So what we need to take away from this is that we're still practicing comparing numbers. Biggest thing is we need to be able to compare decimals and fractions together, also percents. So that's something that you should be able to do, compare fractions, decimals, and percents, and negative numbers. So that's it for today.